Hosting provided by Host Tornado. They offer website hosting packages, dedicated servers, and VPS solutions. Host.t.net.
Programming Throwdown, episode number 7, Objective-C. Take it away, Jason.
Hey, so I'm biking to work now, which is just pretty awesome. I didn't know if I was going to, like it because, I like the exercise, but then there's this whole, you get to work a little bit later. I mean, it might take you like an hour to bike 5 miles or something, right? So you spend a lot of time on the bike and you kind of have to, shower afterwards and stuff like that.
You are such an overachiever. I'm just saying it.
Showering is an overachiever. What does it say about you?
No, riding your bike.
No, but it's super fun. You get to feel there's something weird, like there's something invigorating about like
almost
literally
dying?
just taking yourself to work.
Oh.
Yeah, well that too. But people over here in California are actually pretty nice to bikers. Like in Florida, I feel like if I had pulled some of the stunts I pulled here, I would definitely have been killed. Like actually, if you're biking, and they have a bike lane here, which is pretty cool. But if you're biking in the bike lane, which is on the right side, and you need to make a left turn, you can just swing over to the left lane and take up a whole car lane, until the turn signal goes, and then, make the left turn and then swing back out to the bike lane.
Yeah.
And this only works because everyone's in on it. Like the cars know you're going to do it. You know you're going to do it. You stick your arm out.
Make sure to do your hand signal. Yeah. We used to have to do that when I was at school and, going to university. That was how it was. You had to ride. And that's actually the right way to do it. You have to ride in the turn lane and block traffic. And people would honk at me and get mad. And that was really scary. But that's the rule. Like that's what you have to do to make the turn.
Yeah. Your only other thing you can do, and I've done this, like, I'm still doing this today on a couple of the intersections where I have to make lefts because I'm just not comfortable yet. You can walk your bike, like, along any of the pedestrian paths.
Right.
But technically, it's against the law to, ride your bike, like, on a sidewalk or a crosswalk.
Where there's a bike
like
lane
that.
or something, yeah.
Yeah, right. Or even where there isn't. I believe the rule is if there's no
Really?
bike lane, you're supposed to take up a regular lane of traffic. Or just kind of get over to the right. So
consult your lawyer, please.
Yeah, that's right. But it's a lot of fun, and you get some exercise, and
that's awesome, dude.
Kind of digging it.
I could use a lot more exercise too, but I'm glad you're getting. Hopefully, you'll just get enough for the both of us.
Okay. The one thing about it, though, at least up until now, maybe I'll actually build muscle, but as long as I'm still kind of like indistinguishable from a skeleton, I'm like perpetually sore. Like every day I'm sore because you have this like 8-mile bike ride or whatever. So even if you don't work out, you're gonna be sore. So
what I want you to do is mount the camera to the front of your bike, ride the bike. So then you can upload that video to me, and then I'll ride my stationary bike. Okay, I'll sit on my couch and watch you bike to work.
Oh man, I'm totally gonna call. Let's just say somebody I know who may or may not be in my family, and I have no brothers and sisters, would watch Sweatin' to the Oldies and just like sit on the couch eating like Cheetos. And the guy, what's his name? Richard Simmons, right?
Yeah.
Richard Simmons is like, "You're doing great, honey. You're doing great." She's just like
more
sitting there like
cream.
eating Cheetos. Yeah. Keep going.
Don't stop now.
Yeah, that's right. He's like 1, 2, 3.
Really reach for it.
Yeah, that's for when you're at the bottom of the ice cream container.
Or when it falls onto the ground.
Oh man.
Okay.
So we have kind of a mini news segment today because we want to talk about how we got into programming.
But, thanks to a viewer or listener email.
Yeah, a listener suggested that we cover Objective-C, which we're going to do, as you know, and also suggested we kind of talk about how we got into programming. I think that's really good, 2 excellent suggestions. And in general, if you guys have any, feedback that you want to give that involves, future episodes, definitely, bring that to our attention.
Yeah, it's nice to know that we actually do have people listening to this. Besides our moms. Right. Hi, Mom!
Hey, Mom, how's it going? We're I think we're the number 8th or 9th podcast on iTunes if you search for programming, which is really awesome. Yeah, I mean, and some of the ones up there are like Stack Overflow, which is going to be a challenge, but I think we can take them down.
Yeah, Joel Spolsky better watch out.
That's right.
And you said we broke 25,000 downloads. Is that right?
That's right. 25,000
That's
downloads
amazing.
yeah, something like close to 2,000 unique IP addresses grabbing episodes.
So some people are downloading
yeah.
it more than once. That's pretty cool. Not sure why, but that's awesome.
Yeah. Some people, I think a lot of people, at least the ones that have talked to us, are getting it on their mobile and getting it again on their computer and things like that, which is pretty awesome.
All right, pretty good. All right,
So
so first item of news we had was the new Wii. We talked about that. It was that last episode of the episode before.
Yep.
That was it going to come out? And sure enough, at E3 they announced it. I guess that was last week, and it's actually kind of interesting. The first pictures I saw was of this weird like tablet device. I don't know if you've seen these pictures. The thing looks crazy.
Yeah, it looks awesome. I mean, we talked about this on the last episode, how they tried to do this kind of experience with the GameCube and a bunch of GBAs, but this sort of forces the experience onto you, and I thought that environment was incredible. So
yeah,
I'm really
and I kind of didn't believe it, and then I saw the pictures, and I was like, that looks stupid. But reading people who actually tried it said it is really fun and really amazing. And like you said, with the Game Boy Advances, that's what they tried to do before, but supposedly, I guess they executed it this time really well. And people said that, you can basically have the normal Wii remotes for everybody else, and one person has this tablet screen, and they can kind of be like a different player than everybody else with more information or a different world view than everybody using the TV screen. And so you can kind of get this, like, different players have different roles dynamic at an even fundamental level.
Yeah, I mean, this mechanic has been around forever. I mean, you had the idea of even Dungeons and Dragons. If you ever played that in like middle school or high school, or even I know people who play it today. You have this idea of the dungeon master, who sort of he has information that no one else has, and he has sort of a certain amount of control, and is sort of more like the moderator. As the Wii has sort of taken over the family demographic, you could see playing this with your kids and sort of being sort of the dungeon master and help guiding them to having like even more fun than they could have just playing by themselves on the computer.
Cool. Yeah, or having it for your football game so nobody can figure out what play you're choosing, or
Yep.
Yeah, it's kind of cool. And it's supposedly going to be a big upgrade. They're going to be said, I think, 50% faster or more hardware power than the PS3.
Oh, wow.
So, I'd said the same thing, like, oh, that's pretty good. And then I saw some commentary, which was a good point, which is, yeah, but the Xbox 360 and PlayStation 3 are many years old now. Like, they better be able to surpass it. And like right now, computers are like an order of magnitude more powerful than a PS3 or an Xbox 360. So they're actually really far behind as far as raw power goes.
Yeah, I would take that with a grain of salt though, because these are like specialized processors,
and they can optimize them because everybody has exactly the same hardware, so they know what it's going to be.
Yeah, exactly. I mean, remember the Nintendo is like what 10 megahertz or something, but we couldn't emulate it until you had like at least 20 times that. So you could do a lot with not that much power if it's specialized.
Yeah, but it's still an interesting point that although they're going to leapfrog everybody else, that they'll probably be absolutely crushed when the next, the PlayStation 4 and the Xbox 720 come out.
Yep. I mean, I think what'll happen is, putting my visionary glasses on, is the next Xbox and PS that come out will probably support 3D if they don't already, and we'll all be saying, oh, how come the Wii is the only one without 3D? Kind of like we're saying now, how come the Wii is the only one without 1080p?
But I guess they're not going after the visuals. It's more about the gameplay experience and these controllers, and they really led the way. I mean, now with PlayStation, you got the PlayStation Move and the Xbox 360 Kinect, which have been successful in their own rights. But I mean, they all came years after the Wii introduced this motion controller.
Yeah, that's right. That's exactly right.
So
cool, man.
All right, you have any news?
Yeah, so I'm going to talk about something not as sophisticated or eclectic as the Wii. I'm going to talk about Duke Nukem Forever. This article is titled Duke Nukem Forever, barely playable, not funny, rampantly offensive.
Okay, and, that sounds like a glowing review.
Yeah, that's right. You can imagine where this is going. But I saw the
don't give any
preview
spoilers.
videos.
I don't know if there's. I've not played these games, but I don't know. If
I
you can
haven't played it either. Actually,
okay.
I didn't know until today that the game was out. So, which is kind of a testament to how bad it's doing. But yeah, I mean, I think that I saw the preview for it, and they're sort of really going after this niche market of people who like want to have sort of like nudity in their games. Like even I don't know if have you seen the preview
No.
for this game? So even the boss is basically the top half. It's sort of like this.
Keep our clean rating.
Yeah, yeah. So keeping on the clean rating, it's basically it looks like top half of a naked woman, but like if you had textured that in such a way and changed the face to make it look like a monster, like a half
Weird.
naked woman torso with a monster head. So it's like there's just and even the preview is just littered with nudity, and so it's sort of I feel like that's sort of what they're going for, and this article really sort of pokes at the huge weaknesses of this game, and I thought it was a funny read, so I definitely give it a glance.
Okay. Well, we had 2 news stories. Both were gaming related, so next week we'll have to mix it up and give something actually programming related.
Yeah, for sure. And there are some programming news articles that I was reading, so we can definitely deliver on that.
We're trying to be more exciting.
Yeah, yeah. I mean, the hip thing. Video games are hip.
We want to be with the young kids.
I was playing, just an aside, I was playing Demon Souls, which is this really hardcore game for the PlayStation 3. And I don't know if I'm going to make it through. Like, the graphics are beautiful, and the experiences, it's like I'm getting a lot of enjoyment out of the game. But basically every time you die, you have to start all over again, kind of like those old Nintendo games. And I'm just so sick of playing like the beginning over and over again that I just don't think I can tough it out.
That sounds pretty brutal.
Yeah, definitely.
Oh, okay. All right.
So go ahead.
No. All right. So we were going to talk a little bit about kind of the reasons we got into programming and some of our early days, and try to remember, clean out those cobwebs, and try to think about what it was like, and any sort of advice, I guess. So I guess you go ahead and start it off. So how did you get into programming?
Yeah, so I started programming really young. Actually, I come from like a lot of computer science majors in my family, my extended family especially. And so my cousins were kind of teaching me how to program, and they were teaching me basic and how you do like print your name, go to 10, and it would just spam your name on the screen.
I remember that one. You're like, oh, yeah, I crashed it with my name. It's awesome.
I know. It's like, and so it's sort of like, it's like there was nothing, and then I created my name like an infinite number of times, or just a really large number of times. And so that idea of being able to create something from nothing has sort of like pervaded all of my interests in programming thus far. Like I've worked on this Underworld Hockey Club, this video game that I made from scratch, and I really wanted to see a hockey game with physics, where when you body check the person, there's some physics engine running. And it was kind of funny, and just another aside, I was looking at video games at Target the other day, and NHL 2011 has come out, and on the back of the box it says new physics simulation, like every hit is unique. And I was just thinking to myself, it's so funny because I did that in like 2008. And so that idea where
you should sue them.
Yeah, that's right. I'm gonna sue Sony too, because I'm thinking of the PlayStation 4 right now.
Oh no, you're in
trouble. But yeah, the idea that one person just in their basement can create something that usually takes a whole team of people, or can change the entire world, can create a project that's downloaded or used by hundreds or even thousands of people. That is something that's sort of unique to programming. I mean, there's many different arts. There's painting, there's sculpture, there's writing, but few of those arts allow you to influence and allow you to get inside the homes and the minds and the lives of so many people as computer programming. I mean, you could write an iPhone app for. I was talking to somebody today who wrote an iPhone app for deer hunting. It's like the number 2 or number 3 app. Like every deer hunter needs this app, and even people who don't like deer hunting, for some reason, they're fascinated.
It's like a deer caller or something.
No, what it is, I guess it keeps track of like deer like migration or something, and also it's sort of like a user-driven content. Like you can specify like if you know good places to hunt and places to hide where the deer are and stuff like that. But the idea that just someone
so it's
in their
like
spare
Foursquare
time,
for the forest.
yeah, it's pretty much it's exactly it.
I
Just
checked in at the deer stand.
Someone in their spare time just made this app and it completely took off. And I think that,
cool.
You can be like an amazing painter, but often you need different sponsors. You need to go to galleries. You need to, get your foot in the door. And, now with the internet, of course, all of that is changing. But definitely when we were young, that was the case. But with computer programming, even back then, before, the internet had really taken over and things like that, when we were very young, there was this notion that like one guy, like you'd play Pitfall for the Atari and it was like made by this guy. Like that guy made that whole experience. And you'd go to the movie theater and there'd be a cast of hundreds of people to create a movie. So this idea that you have just this incredible power is sort of what got me into programming.
And I think that happens even to today. I mean, what is the story? I mean, I'm not completely familiar with the guy who wrote Minecraft, right? He was pretty much by himself until, I mean, now he has a team, I think, but he spent a lot of time doing it, but he pretty much did it by himself, right?
Yeah, I mean, he worked on Worm Online, which is sort of an MMO that was kind of trying to be like Minecraft. So it was an evolutionary process, but still, I mean, he created Minecraft himself from scratch. I think his online pseudonym is Notch.
Okay, yeah,
I forgot his real name, but
Marcus
I think his real
Person.
That's what it is. Yep. But yeah, so even today, one person can make a gigantic impact on the world with programming.
I mean, he made like hundreds of thousands of dollars selling his beta version of his game.
Yeah, he made millions, I believe.
Oh, millions. Oh, okay.
I think so. Yeah. So what about you, Patrick? What made you get into programming?
Yeah, so I guess a little similar. My family, even my immediate family, my father does programming, so that always is kind of there. People always, ask me, and I share this story a lot, and I'll share it in a minute about kind of how my dad was at programming, because a lot of people know my dad and know that he programs and writes code and stuff, and are kind of familiar with that, so they ask me how that was growing up with that. And I mean, it's hard to say. It's like one of those things you don't know growing up another way how you would have been or if you would have been different. But, I feel like through his doing or through my mom or through some combination of just family, that you always had this thing about solving problems. It wasn't just, the answer to something was never just told to you. It was always, kind of asked as a form of a question. You kind of had to try to figure out yourself. And so that kind of solving puzzle aspect always, led me to how do I get things done? How do I find answers? And, that eventually played well with the first few forays into computer programming, similar, writing some little basic thing that just followed the tutorial and, oh, look, it's printing out my name or it's converting a temperature or whatever. And it was just kind of cool to see it solving a problem, to figure out how do I express this thing in my head for the computer to do. And even today, when I explain to other people about programming, a lot of people just look at me with the glossy-eyed stare, like I have no idea what you're talking about. But this, how do you tell a computer to do something? Even something basic that humans can do really simply, like one of the first things you learn in classic academia about programming is sorting. And a human has like all these different ways they might sort something. But then if you say, well, how would you codify that? How would you write down a set of rules or steps, algorithm, to use a word, that says how you do that sorting of, those playing cards? And they kind of have to think about it. And, a lot of them, have trouble even figuring that out. It's like, yeah, try doing that for like all sorts of problems all day long, know? And to me, that's exciting. It's like, oh, this is fun. And you work really hard trying to solve some little bit of code and then, just get that excellent feeling of accomplishment, even if nobody else appreciates what you just did. And so once I got to that point, I was hooked. And getting there was an interesting task. And I guess it was just influenced by the fact that even my grandfather did write code at one point and worked on some software stuff that was, pretty early on. And so I guess kind of unique being as fairly young as I am, and being a third generation programmer. I guess that's a pretty good story. Not a lot of people have grandfathers who program computers.
Yeah, it's ironic because my grandfather also worked on some of the first computers, like with the vacuum tubes and everything like that.
Oh, really?
So
so yeah.
maybe
so,
there's a genetic component to it.
Maybe, I don't know. But yeah, so not a lot of people can say that. So that's kind of a kind of badge of honor, I guess, in some ways. It's kind of cool that you can always say nerdy things and know somebody in your family gathering won't roll their eyes.
Yeah, I feel like a lot of people, a big part of problem solving is being able to, I guess to use your word, to codify intuition. I was playing Professor Layton with my wife the other day.
Oh, yeah.
Yeah, and it was one of those problems where it's like, your brother is twice your age and your cousin is 6 years older than you and half your brother's age or something like that, and somehow like those there's like a set of constraints that like, and then it's like, what's your age? And the constraints are such that like your age has to be some exact number.
Right.
And so I'm sitting here like writing formula and trying to, figure it out and solving a system of equations. And my wife is just trying different numbers, like 5. Oh, 5 didn't really work out. 5, if I have 5, then my brother's age is -3. So let's try 7, And by the time I was done, she had already like solved it and moved on to the next question. But when I was done,
Jason.
Yeah, I know. But when I was done, I had solutions for. I mean, I had the solution, but in a way that like a computer could have solved. So in other words, I could have written
another
a program.
Problem, you could have solved it in no marginal time.
Yeah, exactly. And so that's really the thing. A lot of people can solve problems, but being able to do this almost like meta task of writing a program to sort of solve an entire class of problems is really super challenging. And I think that's one of the funnest parts of being a programmer.
Yeah, it definitely is fun. And, like you said, the sense of creating something, even if it's not something physical-ish, like a game or art or music or whatever, but, even just creating programs that run on the computer is kind of fun and exciting, and building them up. It's kind of like Legos in a way. You have all these small pieces and you build them into bigger structures. And there's a beauty that's hard for outsiders to understand, but it's kind of cool if you know what's going on.
Yeah, for sure.
And then also being able to think when you see stuff in movies that are 3D graphics or video games or jumbotrons, and you kind of know what goes into making those work, because so much of today's society is culture. I don't know what you say, but so much of what we interact with every day has computers in it or has some sort of code running to help either generate it or run it or control it. And so kind of knowing how that works is very powerful.
Yeah, and I mean, my opinion might be biased, but I've always been under the presumption that everyone should know how to program. Like not a specific language, it doesn't really matter, but just, a program is basically a set of instructions with certain basic structures like control loops and, if decision statements. And just the idea of, being able to describe what you want to do, regardless of, you could be whatever, like a janitor, or it doesn't matter, but being able to describe what you do and how to do it in a way that's programmatic, I think is important to any discipline.
Yeah. So let's talk a little bit about our first kind of, early experience. We talked a little bit about BASIC, but I know like when I first started, I did a little bit of basic stuff, but I never really got past, just kind of messing around. But then I picked up a book on C programming and started there and started to write some code, just kind of entering the examples there. And I remember kind of trying to work through the book and, not at that point, I realized that it was kind of looking back, the first time I really started to click is taking the examples, putting them in, but then not just moving on or just reading the examples, but actually typing in the examples and then like changing it. So I had, for instance, like a program that converted Celsius to Fahrenheit. So I said, okay, well, let me make one that goes the other way, Fahrenheit to Celsius, because it should be almost the same, right? So making little tweaks like that and making it my own, and that really led to understanding. And so that's actually kind of where that funny story I was talking about earlier came from. So I was writing, this program to do temperature conversion. So I was pretty excited that I had, modified this example. It was pretty dinky. I was pretty young. So I got my dad to come in, and I'm like, oh, hey, look what I wrote. I wrote this thing. It converts, Fahrenheit to Celsius. So I think he, is like, oh, that's interesting. Let me see. And so he types in, some temperature, and it converts, and he's like, oh, okay. Then the very next thing he does is he goes negative 9999999999999, and he just keeps typing nines for a while, and then pushes enter, and it crashed, and he goes, oh, your program's broken, you need to fix it.
Oh, that's so harsh.
So
oh my God.
Another thing that I learned quickly with programming was and I think sticks with me today is writing kind of error proof code, or at least error resistant code, or really thinking about how are you going to test this and make sure it doesn't crash, along with how are you going to make it work.
Yeah, that's funny, man. That's intense.
So needless to say, today I'm really good at breaking other people's code. People always bring code to me and say, this is ready, hey, can you test it out for me? And I say, yes, I would love to. And pretty much within a matter of minutes or seconds, I have it crashed.
Oh, nice. Yeah, for me, historically, I started off actually writing. I did a lot of writing when I was really young, and
writing books, comics, poems.
I know. I wrote a lot of kind of like short stories.
Okay.
And I read a lot, and I wanted to make a choose your own adventure. I've actually made a few choose your own adventures on a typewriter, and
that's pretty hardcore, dude.
It was really hard. I mean, the worst is the typewriter is you make a mistake, you have to just kind of keep going, and I decided, I want to make a choose your own adventure on the computer. So I started off in this program is the print shop. I don't know if you ever used that. I made greeting cards and stuff.
Yeah.
So I made I used the print shop and made like a set of greeting cards, and it was like go to page 3 or whatever. It was pretty epic. I still have it actually. I was going through my stuff and I found it. It was called The Race That Never Ends, and it was like 8 pages.
I think I've seen this before. If you want the intelligence test, turn this paper over. If you want to see the intelligence test, turn this paper over. It just says on both sides. Okay, sorry.
It was so funny because it was like, do you want to go left or right? And it was like, do you want to go left down the dirt road or right on the ocean? And if you go left, you die. But like, there's no context. It's like you just died. So you should have picked the dirt road, dummy.
So did you get inspired to do that from playing like Zork or another text-based adventure?
So kind of a weird story. My parents did a lot of like shopping and like garage sale, flea market, that kind of thing. Like that was a common like family outing. And this one flea market, this guy had the Fighting Fantasy. Have you ever heard of these books?
No. I heard them from you.
Oh, okay. There you go. They're basically, and there's an iPhone app for them, by the way, now. Someone's converted them to like an iPhone app, which is pretty epic. But it's basically like 400 sections, and each section can be from a page to, even a few lines. So a 400 section choose your own adventure book, like this massive choose your own adventure book. And so that's really what got me started into trying to write my own stories and my own choose your own adventure books. After reading tons of those, I bought the whole set of like 36 or something books for like $10. And so that really what started the whole thing. And then I moved on to basic, you're writing different stories and that. And then from there, it just kind of went on to writing games, and from games to programming, websites. And then it just kind of one thing led to another.
Yeah. I mean, I guess that's a point too. I did a little bit, I guess it was around the same time or a little bit after, when web browsers were first picking up, and, not that they were just being invented, but, I guess just becoming mainstream, as it were, but that started doing, writing HTML, which I guess we should point out is a little different than programming. It's more designing and laying out a page. If you do JavaScript, right, you get into programming, but doing actual HTML is slightly different.
Yeah, I mean, there's just some of my best memories are just geeking out to produce something like really crazy. One time I wrote like a little 3D engine in Flash, just using sprites. And then I made this website where when you went to it, based on the time of the day, it would show you like this scene. So it was like this, there's like trees and like a lake and some rocks, and the sun would kind of go over the scene.
Wow.
And so if you came in the evening, the sun, like the wavelength, like I just made the wavelength a function of time or whatever on the light that was being emitted from the sun. Mm-hmm. So it'd look like it was the evening, and at night it'd be just pitch black. And it's just some of the times like you can create something just like totally crazy. And this was like Flash was fairly new. ActionScript like I think 1 or 2 or something like that. So it's like that's something that like nobody else had ever seen before, you know?
That's pretty
So
nerdy, I'm not gonna lie.
yeah, so a big part of it is just yeah, being able to make something completely crazy. And the technology is evolving so rapidly that any of you guys out there can be on the cutting edge and could be, maybe as we talk about Objective-C, can be using Objective-C to make something on the iPhone that nobody's ever seen before.
So let me ask you a question.
Sure.
Do you think that it's more important to pick a language that people say are good to know or good foundation languages, like people would say maybe Java or C++, or if you have some task you want to do, learn the language that does that task? Which one would you recommend for a beginner?
I think honestly it depends on what the task is. So, I mean, clearly if the task is an iPhone app, it's going to be Objective-C. But, if the task is a website, well then maybe you should do that in Python or PHP. Or if the task is, a desktop application, then maybe you should try doing that in Java. So it really sort of depends on what you want to do. I think that the biggest thing for someone who's just starting out, I would say, is to pick a project. Like once you know what you want to do, then just you can use these podcasts or you can use any of the resources out on the internet to try and find a language that suits your needs. Because in the end, not to be too blunt, but in the end, your first programs are going to suck, and they're almost certainly going to misuse the language. So, you might be writing in Python, but in a way that doesn't, accurately reflect the strengths of Python. Or this, and this happened to all of us. I wrote this beat 'em up, kind of like this Double Dragon beat 'em up game MMO that you could play in a Java applet, and it was terrible. I used all these different multi-processing libraries that I didn't have to do any of that for, and just the whole thing was the architecture is a nightmare. But I learned a lot, and I think that those lessons can be gained in really any language. So if your project is web-based, if it's an applet, use Java or Flash. If it's a website, you can use Python or PHP. If it's the iPhone, use Objective-C. Just pick the language that best reflects what you want to do.
Yeah, I'd agree. And, I definitely, I think you hit upon a good point I wanted to call it specifically there, which is that you'll mess stuff up and that'll drive you learning new parts of the language. So you'll go through some tutorial and it'll be really boring. Like, I just want to get started doing my thing. And you'll start doing it and you'll, for instance, you only know how to do while loops and you don't know how to do for loops yet or something. And so it'll be terrible and you'll eventually get frustrated, go, there's got to be an easier way. And you'll go look up and be like, oh, that's it. I just do that. And that'll lead you how to learn, and that's a valid way to do it is, pick something you're trying to do and then learn kind of ad hoc as you need the skill to do something that you're not able to do with the ones you currently have.
Yeah, and definitely, unless you're doing this with, a core group of people and you're looking to make a profit or it's your job or something like that. But if you're doing it as a hobby, definitely reach out to the open source community, post your project on Google Code or SourceForge. Get some people interested, or at least if you don't want to get people interested, make your project public so people, who are interested can contribute. And that's one way to learn a tremendous amount. My first project actually that I open sourced was JISOMan, this JavaScript isometric engine, and it's completely obsolete now. But at the time, it was pretty cool because there wasn't any OpenGL rendering in Java or anything like that. So I got a lot of help from different people who really taught me how what I was doing was terrible. And taking their advice made me a much, much better programmer. So definitely reach out to the community. There's tons of people just like you love to program. And, anytime you make something public, you're almost guaranteed that somebody's going to look at it.
And definitely stick with it because it is hard. It's frustrating. And, I've seen so many people on the internet do it, and I was here myself. But, they decide, I want to make, I don't know, what's the big first-person shooter now? I don't even know. Call of Duty Modern Warfare.
Duke Nukem Forever.
Duke Nukem Forever. Okay, so you played that game and you're like, oh, I want to make that. Okay, well, you got to understand, that takes a team of people. In the case of Duke Nukem Forever, like decades. But in the case of another video game, like years, and millions of dollars to make that. And that's not to say you can't make something fun, but it's to say that you got to break that down and start learning what you don't know. I mean, that's half the battle is, figuring out what it is that you don't know so that you can go learn it. And people say, I want to jump into making, an iPhone game. Well, that's great, and that's a good inspiration, and that'll keep you motivated to learn what you need. But you got to start. Don't think the first thing you're going to make is, some crazy 3D, phone game. First start with make tic-tac-toe. And it sounds stupid, but figure out how to do it because it'll teach you a lot. It'll teach you how to interact with the screen. It'll teach you how to detect an end game, like the game has ended, how to start it over, how to have a game loop. I mean, you'll learn tons of stuff just writing tic-tac-toe. Say, okay, I'm done with that. All right, write hangman. Write snake, the little snake that moves around the screen and eats apples or whatever. And doing that will begin to teach you things, and each one being more advanced will make you learn stuff. But kind of go through that because if you try to skip to the end, you're just going to get frustrated and give up.
Yeah, that's definitely true. And I think that, if you go for something huge like that and fail, you won't really have anything to show for it. If you want to go for something big, like some big 3D platformer like Duke Nukem Forever on the iPhone, you can break it down into modules and make sure that this is true whether you're a novice or an experienced programmer. Make sure that each piece is measurable. Like start off with a little ASCII art top-down thing where you're just running around picking up ammo or something. Like you're like a little @ sign running around some world of periods, like collecting equal signs. Like start off there and work your way up to the game and make sure that you're constantly rewarding yourself. I feel like the biggest, the projects that I completely failed on were ones where I didn't have these intermediate goals, were ones where I had this end picture in mind, but I didn't have the steps to get there, and I didn't have products to show at each level. If you can show the @ sign running around collecting equals glyphs or whatever, that's something that somebody else on the internet can say, this guy, at least he's doing something and he's on a path forward and I want to join this project, and even just to yourself, you could show your friends and be like, look, I'm a step towards making something awesome.
Yeah. And then they may even say like, well, that's kind of silly. This game's boring. Well, what have you made?
Yeah, that's right. Or they might give you like really, important feedback. They might say, oh, these equal signs are too far away.
Or they look like the two minus signs on top of each other or confuse me with the equal sign.
Yeah, that's right. And, you might actually learn some of the gameplay mechanics just from your little ASCII art drawing.
Yeah. And I think you can get involved in big projects, but I think you got to get in with other people because they'll help teach you, motivate you, show you what needs to be done. And so I know there are some people who definitely learn programming by getting involved in open source projects and starting off by, going through and reading the bugs and, trying to fathom how to commit some of the bug fixes, or even just writing documentation, which forced them to go read the code and think about things and get involved. And then slowly but surely, they began to understand more and more about what was going on to the point where they could write their own stuff. And that's another way to approach it. I think that's probably a little more unusual. I know a few people who have done that, but I think more typical is people kind of starting with small things and building up.
Yeah, because usually, it has to come from you. So, I mean, if typically people want to produce something, that's why they get into programming and open source stuff. It's sort of like, how can open source make me do something awesome? Like, I don't know how 3D programming works, but here's this open source 3D engine that does a lot of that heavy lifting. But yeah, I mean, I have seen cases where people have started off just I want to contribute to something and start reading documentation, getting familiar on how the technology works. So yeah, there have been both cases.
And let's not forget another important reason to learn to program is like having the ultimate geek credential.
Yeah, that's right.
Few classes of geeks are more geeky than programmers.
Yeah, I mean, like if you thought band was cool, programming is super cool. Yeah. So, what is your tool of the bye week? Now that we've got everyone kind of jazzed up about programming and things like that.
Yeah. So hopefully we haven't lost some of our more interested viewers, or they've skipped ahead to this point. But that's okay. I think we got to understand there's people of all levels out there, and maybe some people could relate to ours, or at least laugh at us at how silly we sound. But my tool of the bye week is something I actually just found called Flow Diagram, or Ascii Flow Diagram, sorry. And on the tune of making your own first-person overhead shooter, or I guess that's third-person overhead shooter ASCII art game that Jason's brainstorming here on the show, which I fully expect to see by next show, because it sounds pretty awesome. This tool is a web tool that allows you to make flow diagrams in ASCII art. So you can kind of draw boxes and arrows and lines and show the flow of a program, or of, I guess, anything that wants to show data flow or any other kind of flow. And then, you can copy. It does it all text-based, ASCII-based, rows and columns. Then you can copy and paste that into pretty much anything at that point, into your code, into comments, into like a mailing list post, or just anywhere. It's, as opposed to trying to make a picture and draw something fancy and complicated. And the nice thing about doing ASCII art is it's really easy to edit, right? You just go add a few more dashes or pipes here or there and change it to how you need. So yeah, I thought that was pretty cool.
There's so many times when the best documentation for something is the source code. And so, let's say you used a bunch of training data and came up with, let's say you're making a breathalyzer, right? And you came up with a bunch of training data. You got a bunch of your friends intoxicated, and then
I thought you meant people with bad breath. So you got people to not brush their teeth.
Oh yeah, so you get people not brush their teeth and then breathe into this breath sensing device, and it spits out a bunch of numbers. And using the different numbers it spit out in your friends' testing mouths, you develop testing data and come up with some equations. And you did all this stuff behind the scenes on your TI calculator or whatever. And then you came up with the answer. It's 42. If you take the output of the breathalyzer and you multiply it by 42, you get the
stinkiness
1 or
of
a 0. Yeah, that's right. A stinkiness between 1 and 10. But you did all this work behind the scenes that nobody knows about. They just see times 42, and they don't really know what's that code doing there. It doesn't make any sense. So you would love to sort of give them a graph, or draw them a picture, or give them a little flow chart of what you did behind the scenes, and just embed it into the code. And that app lets you do that.
Yeah, I just found it, but I think I'll be using that, because I've done some stuff like this and I had to do it on my own. That was kind of annoying. So this person, I'm sure, was in the same boat, and they got tired of doing it and said, I'm just going to go make a little web app to do that. Good for them. Yep. I'm glad.
Yeah, it's awesome. So
what about you? What's your tool of the bye week?
My tool of the bye week is actually JavE, which is very similar.
Is that French Java?
That'd be pretty awesome.
.de, is that German then?
Yeah, so this would be German. It's a German website. And JavE stands for Java ASCII Versatile Editor. And as you can see from the website, it's basically an MS Paint, but for ASCII art. So you can sort of use your mouse and draw cool lines and shapes and draw bubbles, and it lets you sort of draw different types of borders and embed your text into those. It can also do image to ASCII art. So it
nice.
can, you can give it like a JPEG or something, and it'll turn it into ASCII art. And so this is the same kind of thing where you can wrap a comment block. You can, let's say, for example, you have a bunch of graphs. You can export the graphs to a PNG from Excel or from OpenOffice. You can import that PNG into ASCII art using JavE, and then you can copy paste that ASCII art chart into your code.
I am totally going to do this to all of my programs at work now.
Yeah.
I'm just going to get random pictures of logos and of just graphs of data and paste them into my code, and people will just be like, this is amazing.
I know. I've been getting just kind of beat down on my new job on some peer reviews, because I just kind of I don't really have the style completely down. And maybe what I'll do is I'll take some horrible picture off the internet. I'll take and render it as ASCII art. And there goes the clean, right? The clean rating just went pew. No, but you can have a lot of fun with this, and you can also be pretty productive with it. It's actually quite useful for capturing that metadata. So both of these tools, I think, are fantastic additions to your programming toolbox.
And they're themed this week.
That's right. The past couple of weeks we've had a theme, I believe.
This is good.
Yeah. That one time, I still have to buy that Thing-O-Matic. I think that's what it was called, right?
Oh.
I'm trying to save up enough paychecks or
There's
enough
a
money.
lot of paychecks to save up. It's like $1,000, right?
Oh no, is it? I thought it was like $300 or something.
I don't think so.
Yeah, I have direct deposit and direct withdrawal, so it's like just like all that's left are these tiny increments. Oh man, the Thing-O-Matic is expensive.
So we studied this in school. Money in, less money out means more in your bank account. Well, that kind of rhymed. Right. That was awesome. You got to reduce your expenses, and then you can. Okay, sorry.
Yeah, it's true.
This is not the podcast for that.
I need to stop buying bikes.
Okay. So Objective-C.
That's right, Objective-C.
Now, let's just go ahead and address the 3,000-pound elephant gorilla hybrid in the room.
Okay.
Which is the fact that Objective-C is all the new rage because of basically 1/2 devices, which are the iPhone and now the iPad. So Apple has kind of a history, which I guess we'll talk about in a few minutes, about of using Objective-C, and because of the increasing popularity of iOS devices, I guess as they're known, and Objective-C being pretty much the de facto standard of what you have to program in. And because of that, they've had this kind of resurgence of popularity that they probably didn't even ever have before. And so everybody's wanting to learn Objective-C because it is the enabling technology to be able to you to write the next great Angry Birds.
That's right. Yeah, so do you know anything about the history of Objective-C?
So the way I understand it is that I guess it was originally written as a preprocessor for C, similar to which we haven't talked yet about C++, but C++ has a similar background where originally people were using C, and some other languages like Smalltalk started to come out and introduce these object-oriented concepts, and Objective-C was one effort to try to give C object-oriented support. And they did that by, instead of writing a whole new language compiler, as it were, they wrote kind of an extension of the language, which did become a whole new language, that compiled not to machine code or assembly like we talked about last time, but C code. And then you could use your normal existing, in theory, really good C compilers to generate machine code. And that was adopted by Steve Jobs' small company that he founded when he first left Apple, which was Next.
Right. Yep.
And so there's a lot of stuff you'll see in even the notation for Objective-C, which is like NS object, NS string, which is for next step string, next step object, I believe. So you can still.
I didn't know that. I always wondered why there was all that NS.
I think I'm pretty sure that's what it is. Or either I just made that up and it sounds really convincing. So I'll fact check that.
I think it's true. It makes total sense.
So that's kind of the history. So what is it kind of, we talked about what its, popularity today is for, but what was it good for? What is the reason it exists?
Yeah, so this is sort of a point of contention, right? Because a lot of people would say the reason why it exists is because it's what you have to write in to program for the iPhone. But it does have some strengths that sort of separate Objective-C from a lot of other languages. Many of them are sort of more geared on sort of enterprise writing, safer code, and increasing productivity. So one is that Objective-C is both dynamically and statically typed. So basically, just to cover that again, if you do in C, if you do int I equals 3, you can't just say j equals 4. You have to say int j. That means it's statically typed. So at compile time, you're going in and typing in what the type is of every variable in the system. This is slow, but it prevents you from having these unforeseen side effects. I mean, imagine if you had a round function that rounded a number, and someone passed in the word tree. Your round function, it either has to be smart enough to handle what, to do something when you give it tree, or it's just your whole program is going to crash. So statically typed language like C is safer in the sense that you know what's coming in and going out of all of your functions. And so you don't have to handle all these weird corner cases. And that prevents errors at runtime. On the contrast, dynamically typed languages like Python, they don't have a type. So you just say j equals 4, and then your very next line could be j equals apple, and it handles it just fine. It's just behind the scenes it's going and figuring out what j is at runtime and changing that. So Objective-C kind of has the best of both worlds because you can do int I equals 3, and the compiler will know that that's an integer and it should stay an integer. But you can also use this special term ID. So you could say ID I equals 3. And what that tells the compiler is I can be anything. Like right now it's 3, but later on it could be Apple, it could be a database, a pointer to a database, it could be anything. And so it gives you the strength. When you need to be flexible, like you're writing a user interface and someone might be typing in strings or numbers or whatever, you could be flexible. And when you are doing some kind of numerical simulation where everything has to be a float and you have certain expectations, or you're doing something that's mission critical, you can have that security as well.
That seems kind of powerful, and I think that is something that is kind of appealing. It's kind of a nice feature, although it seems like it might be confusing. And indeed, I've had experience where that can get kind of confusing to have both dynamic and static typing. Something else that I found interesting is it supports object-oriented, and it kind of does it in a way that's different than C++, which is why both C++ and Objective-C kind of existed and coexist, is the fact that it has a different model for doing the calling of functions with classes and stuff. And maybe you can explain this a little bit better, but I guess it's based on messaging as opposed to function calling. So if you have a class in C++ and you want to say, this class dot, foo, and pass it in the number 3, then you're calling a function of that class. You're actually going and invoking some code that's done by a function pointer, what it boils down to. Versus Objective-C, it's a message passing thing. So if you did what's the equivalent syntax in Objective-C for that, you're not calling a function, you're sending a message to that instance of the object that has, hey, I want to have a message of type foo with the contents of 3. And it's up to that class to figure out how to handle that message.
Right. So, that all happens sort of under the scenes. On the surface level, it is very similar to C++ where you're calling functions. But yeah, under the scenes, there is a message passing interface. And so basically what that means is the parameters and actually the function itself that you want to call get packaged up into this blob and then sent over to that class. And so under the hood, what that means is it's sort of what enables the dynamic typing, is this idea of being able to do message passing. But anything that we've talked about with respect to object-oriented in the past still holds here. So for example, you can have inheritance, you can have polymorphism, you could have, going back to my canonical example, your area interface, or I guess a shape interface with a getArea function that's virtual or returns nothing. And then as you implement that shape, you can have a square where the area function returns side times side, and you can have a triangle where the area function returns 1/2 base times height. And at runtime, when you call getArea, you might not even know if it's a triangle or a square because it was created minutes ago and it's been typecasted down to a shape. You might have no idea as the programmer what that is, but the compiler and the virtual machine know that it's that's a square or triangle, and it does the appropriate thing.
Yeah. So, but I guess like you pointed out, I mean that's not really all that applicable to somebody who's trying to just write in the code. It's kind of handled under the hood, but it does serve to kind of explain to some of the more advanced listeners, what is the difference? Like, why is Objective-C still around? And it isn't just used for iOS. I mean, it's also used on OS X in the Cocoa framework. Am I saying that right?
And yep, that's right.
So they use it there for doing a lot of the programming of apps on OS X. Or I guess applications or just programs as opposed to apps.
I think it's still apps. Because
okay.
I think on my Mac it says the Mac App Store, I think.
Oh,
but anyways.
Okay. Yeah, I used to always call them apps. Now apps kind of mean something more specific than I used it for.
Yeah, now it seems to be specific to mobile apps.
Yeah.
And another benefit of Objective-C is it has a really smooth interface. So basically, let's say you want to use some C++, like the Bullet physics engine, in some Objective-C app you're writing. Now, this, for one thing, I should preface this by saying that this applies loosely in the iPhone and iOS world, but this is mainly for people coding on Mac OS X. You can still do some of this on the iPhone, but some of it is very limited. And that's mainly an artifact of just the iPhone trying to restrict you from, coming up with exploits and things like that. It's nothing, inherent to the design or something. It's a political decision. But with that said, you can integrate Objective-C and C or C++ very easily. Now, basically, you create a C or C++ interface in your Objective-C code. And it just sort of mentions what classes there are, what functions there are that you can call, and things like that. And the API is really straightforward. So if you have, let's say you have this monolithic C or C++ application, and you want to write an OS X, GUI for it, that would be very easy in Objective-C because it ties in so well to both of those languages.
Yeah, I did some stuff where I wrote some iPhone apps, and it's it's kind of hard because, like we were talking about before, sometimes the best way to learn programming is with really simple things, and you kind of have to do a lot before you even get the first program up and running on like an iPhone, or I'm sure it's pretty similar on OS X, or even just the most basic C program is still probably like 10 or 11 lines of stuff you have to type versus just a simple one line print in Python.
Yep.
So that's kind of a little bit of a, oh man, this is scary. And you have to write a bunch of lines you kind of don't even know what they mean initially. And the same thing is true in the iPhone, that there's kind of stuff you have to do and set up and work with to even, get something that you can just draw to or write text to on the iPhone. But I kind of, having roots in C, and, I think this would be my advice to people trying to learn Objective-C programming to do stuff on the iPhone, would be kind of learn C first because it's simpler in a way.
Yeah, definitely.
I mean, there's advanced parts to it that are really complicated, but you don't have to worry about the iPhone specific parts. Not only will you have a lot more resources to draw on as far as learning C, you'll have something that's very applicable to a lot more than just the iPhone. And then my experience of programming the iPhone was that I was in there, I would do these kind of things I had to do, this little song and dance to get everything set up the way it needed to be to get the iPhone happy. And then I would pretty much just write C code. So,
yep.
They have all these NS objects you pass around, and I would just figure out how do I get a pointer to the data, the array, and then I would just, do regular pointer stuff in C, and, just do all my old stuff that I knew, have done for years, and am very comfortable with. And I had no problem doing that. In a lot of ways, that code actually ended up being a little bit faster than doing it the way that kind of they recommend to do it, because it involved less overhead. And so it worked out well for my application, at least. Now, I can't say that universally that'll be the case, but I definitely didn't feel hampered only having a strong C background and not really knowing what I was doing in Objective-C. I was still very much able to write a fully functioning iPhone app that did everything I needed to do and was well received.
Yeah, I actually went through something similar where I made a little board game, I guess a board computer game. I don't know. I made a board game, but not having the facilities to print large amounts of stock paper, I created an emulated version on the computer. I wanted it to run on the iPhone, and so I was taking this program that was actually written in Python and converting it over to Objective-C. And it converted over pretty well. So I think that, yeah, you definitely, I think that I wouldn't pick Objective-C as my first language to learn either. I would pick a simpler language like C or like Python.
Something very
to a
much like
lesser extent.
text-based, I think, is kind of key there, as silly as that sounds.
Yeah, I mean, I think that when I read Objective-C, and I don't know if it's because I started in C, but everything seems a little backwards. You know, like it seems like I think things are out of order in certain areas of it. Maybe the way that the things are nested, but I always feel like I'm reading things backwards. I think what it is you how you put the brackets and then you put like the object and the function name inside the brackets as opposed to like object parentheses and then or function name parentheses. Yeah, so that is a little bit it takes a little bit getting used to. But one thing that should be mentioned is that the Xcode, which is the editor IDE you'll almost certainly be using if you're doing iPhone development, has a really nice slick UI for creating the UI for your app. So kind of like how Microsoft MFC used to be, although MFC is the devil, but that's another story. They have this like nice Mac. Actually, Apple did a great job. They have this resource builder where you can go in, drag buttons, kind of get an idea, mock up how your app is going to look, and then you can double click on the buttons to create little stub functions and things like that. So, like Patrick said, if you get a foundation in C or Python or any other procedural language, Java, you could take that to Objective-C and be able to do whatever you need to do on the iPhone there.
Yeah, I'd agree with that. And I mean, if you really want to make an iPhone app and that's really what motivates you, by all means, please go ahead and, learn Objective-C. And there's becoming more and more resources out there to do it. And the stuff you learn there will, just like we're saying, other stuff will apply to that. What you learn in Objective-C will apply to other things.
For
sure.
So
if that's what motivates you, I think it's just a word of caution to be careful to not get overwhelmed by, the kind of graphical nature of this iOS device versus, kind of just starting with simple text-based stuff.
Yeah, that's true. Definitely.
Because graphics does add, it's fun because it's really enjoyable to be able to see, kind of animations and visually what's going on. That's a really fun thing to do. But it does add a whole layer of complexity that is hard, especially for a beginner, to figure out exactly what's going on and all you have to do.
Yeah, maybe we'll take a little bit of time here and talk about asynchronous, because a lot of anything you're going to do with the user interface, and if you're doing stuff on the iPhone or the OS X or the iPad, you're almost certainly going to have to deal with the user interface. As Patrick said, you're not really going to be writing console apps for the iPhone.
Oh, but before we do that, let me interject quickly that we've been talking about OS X and about the iPhone, but GCC actually does support Objective-C as well. And so you can write text-based command line programs that way. I don't really know of a lot of people doing that. The only people I know writing Objective-C are doing it for OS X and Cocoa or iOS. But there are a couple. Also, the LLVM CLang compiler will do Objective-C. So you do have options on other platforms for doing that. But it's mostly supported by Apple and their products. So that's where you're going to find, I would dare to even say, probably 99% of Objective-C development.
Yeah, for sure. Yeah,
okay, sorry. So
no,
asynchronous.
So asynchronicity is something you have to worry about whenever you have a user interface. And basically, you might have wondered this. I write this program, and somewhere along the line, it has a set of instructions. And then when that instruction finishes, my program ends. So how can I write something like a user interface where it's kind of waiting on the user? So you might think of, well, I'll just do kind of like a while true around my entire program. And this while true will just continue to loop and sort of wait for the user to do something. And when the user does something, then there'll be some kind of action. And this is basically the heart of asynchronous programming. So what's going on here is basically you have sort of a while true. So you have some loop that's constantly running. But then within that loop, it sort of asks a series of questions. And so these questions are getting asked, hundreds, maybe thousands of times a second, maybe even more than that. So the questions might be, has the user clicked on a button? Has the user moved the mouse? Has the user done anything? Maybe there's an idle function, has a second of time gone by? There's just a series of questions. Now, all this is going on behind the scenes. You don't see any of this code. But if the user has, let's say, moved the mouse, then look for any, mouse moved functions in the code. And by look for it, what I mean is actually you tell the operating system, or in this case, you tell the application layer.
Yeah, called registering.
Yep. So you might have some function where every time the user moves the mouse, it draws like a cute mouse trail or something like that. In that case, you're going to register this mouse moved function, and you're going to bind a mouse moved callback to one of your functions. So when the mouse is moved, then I'm going to add these little mouse trail pointer, these little graphics. So writing asynchronous code, if you look at the code, what you'll see is some main function that just creates all these callbacks. It just instantiates all these callbacks. Like you might have like main and then, bind mouse move to my trail function, bind user clicked on this button to my submit function, all these binds, and then just a go. And what's going on behind the scenes when you call that go is there's just a loop, and it's just going through and waiting for the user to do something and then reacting to it. So this is something that as programmers, if you're used to writing sort of recipe kind of programs like C or C++, asynchronous programming can seem very scary, but it's something that you just kind of got to get familiar with. And once you start doing it, you'll quickly get the hang of it.
The other thing that's confusing there that is worth pointing out is that if you kind of think about, so asynchronous, just means not everything being synchronized and in lockstep. So if you read a normal C program, it's everything is operates one after the other, and you can follow a line of execution straight through your program. Or if you've got a loop, you can follow it through each cycle of the loop and then to the end of the program, or whatever it means. But it's kind of everything one right after the other. When asynchronous comes in, you don't know which parts of your code are going to operate in which order, which is because you bind these functions to certain events, and you don't know which one might get called before another, and they can be called while you're off doing something else. And so that introduces a kind of confusing thing to your code where you can't just read it like a book. And the other thing is that you have to be careful, because what happens is there's a thread of execution that is responsible for drawing all the stuff on your screen. And so if somebody clicks a button, and in that button event handler, you try to do some complex math, like you try to solve the meaning of the universe. What's going to happen is during that time, the user's going to not be able to get a response out of your GUI. The buttons won't highlight when you move over them. They won't be able to resize a window. And if you've ever seen this happen in a program, that's typically what the problem is. Something's gotten stuck somewhere doing a bunch of processing it wasn't supposed to do in that thread, and now you're not getting a response out of the GUI. So the right way to handle that is in the handle it in the handler, is to push that work to another thread or to something that's going to do that processing that's going to take longer, so that function can return and the GUI can continue to be updated so that the user maintains responsiveness.
Right. So one thing I probably should mention, in addition to in that while loop that I talked about before, where it's checking to see did the user click a button, did the user move the mouse, etc. There's also what Patrick's alluding to, a draw the screen. And as he's saying, if you interrupt that while loop, if you halt that while loop by solving the meaning of the universe, it can't get to that draw the screen. The user moved the mouse, draw the screen, draw the new mouse. It can't do any of that. And so a lot of asynchronous programs will, if you have a threading library, they'll say, okay, you clicked on this button to submit your information to the website. While I'm contacting the website and submitting the information, etc., let's push that off onto a separate thread so that this main thread can continue running. Or let's break this up into pieces. So if you click on, create graph, and it's going to take all this data that you've put into your phone. It's kind of like Excel. It's going to, fit a curve to your data and display it on screen for you to do whatever with. It might break that up into pieces, and it might say, draw the curve, and then the next time it goes through the loop, find some data. The next time it goes through the loop, fit the data to the curve. And so every time you're going through the loop, you're checking, did the user move the mouse, you're drawing the screen, and then you're doing just a little bit of work. And so the GUI is actually being halted, but it's by such a tiny amount that nobody can notice. So these are often the core features you see in asynchronous programming.
But GUI code is definitely more confusing to read than normal synchronous code.
Yeah,
because of these facts.
Right. And internet code is even harder because you typically have hundreds, maybe thousands of users all using the same thing at the same time.
Yeah, which will lead to maybe some stuff we'll talk about in the future, some interesting new directions people are going in web servers and how to handle large numbers of users from one program.
Yeah, definitely. We should definitely get into some more internet topics in the future.
Yeah, those are very applicable, and I think a lot of people are out there doing that. And, we should be careful that, when talking about learning to program, which I guess we kind of got off of when we were on Objective-C, but that, a lot of people will kind of fuss at you about your choice. Oh, I can't believe you learned BASIC, or I can't believe you learned PHP. That's not a real programming language. Sometimes I find that those people tend to be the people that don't know what they're doing. And so they're just saying that because they're ignorant and they're threatened or, whatever it is. It's kind of like the people that make fun of you in school, remember those people? It's typically because they had some sort of huge flaw themselves and they were trying to cover it up by making fun of everybody else.
So
never be embarrassed by your choice. It's
so interesting how, often, like you're saying, the people who are the most despondent are the people who, it's typically that they just they cannot see the benefit of whatever they're, making fun of. But the fact is that all of these languages that we've talked about until now, and likely all the ones we're going to talk about, unless we really start running out of languages, are very popular, and they have an incredible amount of utility. So it's
all about picking the right tool for the right job.
That's right.
And if you're writing iOS programs, that's Objective-C.
That's definitely the right tool, for sure. So we talked about a lot of the strengths, but maybe we should cover some of the weaknesses of Objective-C.
We kind of been hinting around the first one that I have, which is that outside of these uses, nobody really uses Objective-C for anything. In fact, if I understand correctly, Apple kind of released the second version of Objective-C language or the Objective-C compiler, or however you want to phrase it, kind of the upgrade. And that's not even supported by anybody else. Like GCC and Objective-C don't support those language features because there's just not enough people interested in using this outside of the OS X iOS environment.
Yeah, that's right. Yeah, the low user base is by far the biggest weakness. And, now I think that some people have figured out ways to write, apps for the iPhone without using Objective-C. I've seen this Corona SDK. It's a development kit for the iPhone where you can write in, I think, C++. And I don't know what they're doing behind the scenes.
Yeah, I thought there was something. I'm not that fresh on it. I wasn't prepared for that topic. But I know there was a while where they had something in the license agreement that basically said you had to write in Objective-C with Apple's, deemed appropriate development environments. Right. And you weren't allowed to write in anything else. And I think people kind of fussed, and I think they backed off of it a little. But I think in general, that's still their stance, is that you're supposed to always run Objective-C or write in Objective-C. Yeah,
I think that, it's still 99% of the code on the iPhone, I would say, is Objective-C. But yeah, there are ways. I think Boo is a dialect of Python, which can be used on the iPhone in some capacity. But yeah, I mean, in the end, if you're writing for the iPhone, really the best advice is to just suck it up and learn Objective-C. We did for writing our iPhone apps. One of the other weaknesses I would say about Objective-C is that the syntax is, I feel like it's very verbose and complicated.
But maybe that's because we're colored by being C++ programmers first.
Well, I feel like that, but I feel like objectively what I can say is that going back to the strengths of Objective-C, being, dynamically and statically typed, having one thing we didn't really talk about was the different property directives. It's very easy to create properties in Objective-C, but just being able to get that power, and the reference counting, things like that, comes at the cost of the syntax, I feel. I feel like I could be objective and say that a language like C, which doesn't have all the bells and whistles, has a much simpler to read syntax. But again, a lot of that is because
whoa, hang on. I don't know if we can let that fly. C has a simple syntax.
Well,
have you seen some of the C code I've seen?
Oh yeah, C code can be terrible. I guess any code can. But maybe this is a more fair statement. If you're writing for the iPhone, you will almost certainly be doing asynchronous programming, and so there aren't really any canonical hello world. There isn't a large code base of command line, straightforward code written in Objective-C for you to get your feet wet. So chances are, if you're going to learn the language, you're going to take on, an asynchronous iPhone app with many different function calls going all over the place. And I think that's enough to make any language complicated.
Okay. Yeah, I mean, I'm giving you a hard time. I agree that that the language, in my opinion, has a lot of characters that you don't really need.
Yeah, and this is really endemic to a lot of these sort of these sort of UIs. I mean, remember MFC and what a disaster that was? Like, it was like application layer integer pointer, like all of those words strung together just to name a variable for a freaking button on a UI. And so MFC had this problem. Java, even Java has this problem, like new file reader, and then inside of that, new buffered reader, new IO reader. So anytime you start dealing with, GUI user experience kind of things, it's going to become very verbose. And so I think it's just the fact that Objective-C is only used for those kind of applications means that you're going to be reading a lot of complicated code.
I'll agree to agree with that. This isn't much of a our podcast is Programming Throwdown. We I kind of thought maybe we'd throw it down with each other a little more, but it hasn't really turned out that way.
Yeah, well, I think that every now and then we kind of grill each other. I think that we should pick a language that has much contention. Maybe we'll do C++ next time, and one where at least I'm very opinionated. I don't know about you.
Oh, I can take whatever opinion that is opposite of yours. Bring it on.
Okay. All right.
You are definitely wrong.
No. We'll just have a crying match.
Well, to close this up, since we're drifting a little, I want to thank all of our listeners. Thank you for those who have written us some emails and written us some good reviews in iTunes. Continue to do that, please. That helps us, feel appreciated for doing this work. And we enjoy doing it, but it helps to know that it's worth it because people are out there listening to it. And it helps us get even more listeners because it rises us in the ranks so other people can see us. So I encourage you, please it's nice to click the 5-star review and 4 stars reviews. Please 5 stars. And but it's even nicer if you can write a little message and tell us what you like about it. And then if you have something you don't like so much, just write the good things in the review and then send us an email. Or post it on the blog, your comments and critiques, so we can try to make things better. And feel free to post on those. We do on our website, programmingthrowdown.blogspot.com. You'll find show notes, links to some of the stuff we talked about, kind of a little bit of a recap of our discussion in case you can't remember something later. If you have terrible memory, like at least I do. And
same here.
Okay, and Jason too. And, also a link to the podcast if you want to download it. It looks like most people download through iTunes, but if you want to listen to it on your computer or download it for another device, you can find that on the website.
Yeah, and I mean, a shout out to Weston for coming up with both of the ideas for the show, for why we decided to start programming and for Objective-C. So definitely, if you have any comments or suggestions, we do have our ears open, and that was a particularly good one. So
yeah, can't promise that we'll implement what you say or do it, but we'll definitely read it, we'll definitely listen to it, and we'll probably give you a shout out on the show.
Yeah, So I think that about wraps it up.
All right. Well, till next time.
Have a good one, guys.
Take care.
The intro music is AXO by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share Alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.